Assalamualaikum. Okay, we continue with the next lesson. I would like to share with you the value of current and voltage or potential difference in either series or parallel circuits. Okay, now we start with the series circuits. Okay, we have two bulbs. Okay, with the same power rating. Okay, so 1.5 watts and also 1.5 watts. Okay, now what can you say about the brightness of the bulbs? Okay, so both have the same brightness. What can you say about the current that passes through the bulbs? Okay, so we have both two emitters. Okay, so it looks like both have the same current. So see, there is only one bulb. The current that passes through each bulb is the same. Now what can you say about the brightness of the bulbs? Now we have three bulbs with different power rating. 1.5 watts, 3 watts and 5 watts. Okay. So the bulb have different brightness. Now what can you say about the current that passes through the bulbs? So here we have, I think we have the same, we have the same value of the current. So since there is only one bulb, the current that passes through each bulb is the same. But the bulb have different brightness due to different power ratings. Okay. Okay, now we have circuits for electric jug. So the circuit consists of the power supply, the fuse and the heating element and the switch. So what type of circuit is shown? So this circuit is a series circuit. Okay. What can you say about the amount of current passing through the heating element and the fuse? So it will be the same because they are in series circuits. Okay. So if the current passing through the heater is 4.5 ampere, how much current passing through the fuse? So it must be the same. That is 4.5 ampere also. So why is it necessary for the fuse to be arranged in series in the circuit? So the fuse always arranged in series so that it can break the circuit should there be an overflow or leakage of current. Now we have another type of circuits. So we have two bulb, this time arranged in the parallel circuits. Okay. Right. So this is a 2 ohm bulb, this is 4 ohm bulb. What are the reading of the ammeter when the circuit is closed? Okay. So now we have ammeter 1, ammeter 2 and ammeter for the whole circuit. Okay. Okay. So this is the ammeter, the main ammeter 2.25 ampere. Now we have the first ammeter 1.50. The second one is 0.75 ampere. Okay. Now what can you say about the current passing through the bulbs? Okay. So in a parallel circuit, the current is the sum of the current that passes through the bulbs. So I equals to I1 plus I2. Right? 1.5 by 0.75 equals to 2.25. Okay. So now we have another circuit. So this time we want to measure the voltage and also the current flow in the circuit. Okay. Okay, so we start with the ammeter reading. Okay. So oh sorry, we start with the voltmeter. Okay, first one is 3 volt. The second one is also 3 volt. And the third one is also 3 volt. Now ammeter, the main ammeter, the first ammeter 1.5 ampere. Okay. Okay, the second ammeter also 1.0 ampere, and the main ammeter is 2.5 ampere. So what can you say about the current passing to the parallel circuit? Again, we have the I equals I1 plus I2. What about the potential difference? What can you say? The potential difference are the same. Okay. So in parallel circuit, the main current I is divided into each path. Thus, I equals to I1 plus I2. And the potential difference across the path are the same and equal to the potential difference of the battery. V equals to V1 equals to V2. Thus, in a parallel circuit, the current divides itself between each path. So the amount of current flowing in each path depends on the resistance of electrical component in each path. Okay. Secondly, potential difference across each electrical component is the same and equal to the potential difference of the battery. Okay. Alright. Now we move on. Okay. We do some exercise in order to understand more about series and parallel circuit. Okay, the first exercise, identify again. We try to identify series circuit or parallel circuit. Let's say for the first one, so this is definitely from here all through the same path. So this is series circuit. B, we have to divide into 3 paths. So this is parallel. Okay, now we have 3 bulbs. So this current flow, same path. So A and B is the series and separated with C. So C is parallel. AB, okay, AB is series. C and AB are in parallel. Okay. Alright, this one, 6 volt. P is the series, separated into Q and S. So P series, Q and S are in parallel. Okay. Now we have another task to read the ammeter reading. Okay. Alright, so we have the first one, A. So there is 1 ampere. So this is series, so should be 1 ampere. Secondly, also series, so this is 0.5 ampere. So B should be 0.5 ampere also. Now we have a parallel circuit. Remember, 3 ampere divide into 2. And combine again, back again, should be 3 ampere. Okay. So D. Now we have here separate into 2 ampere, 1 ampere. So this will combine again to give you 3 ampere. Okay, so we have a combination of series and parallel circuit. Okay, here F. Okay, we don't know. Okay, here's the bulb, 2 ampere. Here we have another one, 3 ampere. And okay, so we start here first, F. So this is a series. So F should be 2 ampere. And here is 3 ampere. So we combine, so we should get here is 5 ampere. Okay, correct. Now the last one, G. Okay, where should we start? GH. Okay, here is 3 ampere is the total current. So here is 1 ampere. So we have 3 paths. Divide to 3. 1 ampere. Here is 0.5 ampere. So H, here is 0.5 ampere. So here should be 1 ampere. So here should be, I think 1.5 ampere. Okay, H should be 1.5 ampere. Okay, and G should be 2 ampere because 1 ampere, 1.5 plus 0.5 should get 2 ampere. 2 ampere plus 1 ampere should get 3 ampere. Okay, I hope you understand how to calculate the current. Now we move on to the voltage. Okay, voltage. Alright. So this is the battery. Okay, so 2 volt. Here is, okay, this is from the battery. So 2 volt, V1 plus V2. So 2 plus, so this should be 1. Okay, 2 plus 1 equal 3. Okay, about V, here is 3 volt. 3 plus 2, this one should be 5 volt. Okay, C, okay, series, this is series. 2 plus 4 should be 6 volt. Again, now we have series. Here is the total 6. So 2 plus 1 plus 3 and get 6. Alright, now we have series and parallel. Okay, here is 2 volt. So E must be 2 volt also. And F should be 2 volt because parallel circuit, the voltage are equal. Okay. Okay, so we stop here for the second lesson. So we will continue the next lesson to find the what we call effective resistance. Okay, see you next time.